So we talked about redox in terms of the loss and gain of electrons and oxygen, and we also learned about assigning oxidation numbers and oxidation states. And now we're going to put things a bit together and use a more scientific approach in terms of identifying which of the elements or ions or whatever, or one of the reactants or substances, what is happening to it as it undergoes chemical reactions. Is it losing or gaining electrons? Okay, and we're going to use it in a more systematic way and not trying to just guess our way through. And I'm going to use familiar examples so that you can keep track of it. All right. So here we have magnesium oxide that is decomposed into magnesium and oxygen. All right. So what is happening to this magnesium oxide right here? Well, if you look at it, the first thing you need to do is to assign oxidation numbers. So when you look at a reaction and you want to figure out what is happening to it, the first step is to assign oxidation numbers. Okay? So that's what you do. First step, assign oxidation numbers. So let's look at the oxidation numbers for magnesium here. Well, we don't really know. Well, actually we do. It's group 2. And because this magnesium is bonded with another thing to form an ionic compound, well, we know it's a +2 oxidation number. And what about oxide? Well, oxide is a -2. That's the oxidation number for oxide. Okay? And what about this magnesium here? Well, it's an element. It's by itself. It's equal number of protons and electrons. So the oxidation number is 0. And oxygen here, well, it also has an oxidation number of 0 because it's a diatomic molecule. It's a gas. There's equal sharing of electrons between both oxygens. And if you to rip it apart, no one is actually gaining or losing electrons because they are the same element. All right. Now that we've got the oxidation numbers down, what's happening to it? Well, we'll take this portion out, all right, of the magnesium with the +2, the magnesium ion, and we are going to equate it to the magnesium metal that is formed, right? Here we go. Mg2 plus will yield Mg metal, all right? And what is happening here is your number is reducing from a +2 to a 0. Now, a really good way is to figure out where the electrons are. Okay, so second step is to split the equation, all right, and then split the equation into 2, right, the 2 halves, and construct the split equations, we call them half equations, with electrons in it, okay? So we split them up, so basically, I should split them up here. So we have oxide here that is going to give us oxygen. Okay, so we have 2. We have the magnesium and with the oxide. We split it into 2. And now we're going to construct the half equations by filling up the blanks. So here, the charge of the products here is 0. The charge of the magnesium is a +2. So it needs something to neutralize the +2 to become 0. And what can we neutralize +2s? Negative numbers. And those negative things are electrons. So how many charges there in one electron? -1. Right? So you need 2 electrons to neutralize this to get this. So what is happening with the magnesium ion here? Well, it is actually essentially gaining 2 electrons from the oxide to form magnesium metal. On the other hand, we have a -2 charge here and a -0 charge here, right? So this side here is negative, and this side here is 0, and we have to add a number either here or here to make it equal to the smaller of the two numbers. Because remember, we're only allowed to add electrons. So I'm going to add an electron. How many electrons? 2 electrons. So this side of the equation now is a negative 2. And this side of the equation is also a negative 2. And so it's balanced off. So this side here, you are, what's happening to the electrons? You are losing electrons. Alright? So the outside here loses electrons. And so we say it's oxidized. And the magnesium ion here, has gained electrons. So we can say that the magnesium ion is reduced. Alright? Wonderful. Now, what about the next equation? I'm going to rub everything off. Okay? There you go. The next equation we have a reaction happening in aqueous solution. So let's assign oxidation numbers again. So, yep, just lower it a bit. Here, zinc element is by itself, so it's an element. So it has an oxidation number of 0. This is an hydrochloric acid. So we look at our table in the last video, and we can determine that this here is +1 oxidation number, and here we have a -1 oxidation number. This zinc now is coupled with chloride, so what's the oxidation number for this zinc? We don't know, but we do know that chloride is a -1 because it's not attached to an oxygen, so it's a -1. So how many chlorides are there here? 2. So it's a -2 charge. So what's the oxidation number for the zinc? Well, it has to be a +2. And what about for hydrogen? 0. Okay? Cool. Now, when we want to split this up, we're going to figure out like which of the oxidation numbers have changed. And we looked at zinc. Zinc has changed from 0 to +2. So that's good. We will use that. Hydrogen ion here becomes +1 to 0. So it also changed. So that's split it up. So we use that as well. But for chloride, nothing happened here, right? It's a -1, it's a -1. So we don't really need it. All right? So what we're going to do is we're going to split the equation into 2 halves. So I'm going to write zinc, okay? And it's going to give me zinc +2 in aqueous, okay? And then the other one, we're going to have hydrogen giving us hydrogen gas. All right? Okay. So, the oxidation number of this is 0, and this is +2. The oxidation number here is +1, and this is the oxidation number of 0. So, zinc here, what happened to it? Well, this is a +2, so we need to add electrons to make this side of the equation equal to 0. Alright, so we add 2 electrons. So we can say that this zinc here loses electrons. So it is oxidized. Okay? And hydrogen here changed from +1 to 0. So what can we do to make this side equal to this side? Well, there's 2 hydrogens, right? So this should be a +2. So what do we do? Well, we add 2 electrons. And so this hydrogen ion gained 2 electrons to become hydrogen gas. So we say that hydrogen ion gains electrons, so it is reduced. So this hydrogen ion is reduced. All right. So that is how we kind of do this with equations that we're familiar with, and we can determine its oxidation number and what is happening to the reaction and which element is gaining or losing electrons. All right. Now let's go with another example that you've never seen before. Okay. And this is, I found, one of the most popular and important topic, chemical equation or chemical reaction known to mankind. It basically cured world hunger. All right, so we have nitrogen plus hydrogen, and we get ammonia. Okay? So, first step is to figure out which here is being oxidized and which of these reactants is reduced. Well, we'll assign oxidation numbers. It's simple. We know that this is 0 and this is 0 because it's diatomic. This gets tricky. We know that H has a +1, right? So what is N? Well, there's 3 H's. 3 times +1 is a +3. So therefore, nitrogen must have a -3 oxidation number. So we see that N value has changed from 0 to -3, and H has changed from 0 to +1. So what is oxidized and what is reduced? We'll split the equation up. And then we have N3 minus. Then we have another equation where we have H, and it gives us an H plus. Okay? Now this seems a little weird, I know that, but let's keep track. We have the oxidation number 0, and this is a -3. Alright, and the 0, and this is a +1. So, here we have a -3, here we have a 0, so we need to make something, add something here or here to make the charges on both sides equal. But the only thing we can do is add electrons. We can't add it on this side because the more electrons you get, the more negative this number gets. So that's out of the question. Okay? And so we add electrons here. How many? Well, each electron is a -1, so there's 3 electrons. And each... What about this one here? Well, for hydrogen is 0. Here's a +1. So let's add another electron, and the charge should balance out, right? 2. Because there's 2 here, there's 2 here, so there's 2 here. Cool. Alright. So here, nitrogen has gained 2 electrons. Gains electrons. So we say that it is reduced. Hydrogen, on the other hand, lost 2 electrons, loses electrons. And so we say that it's oxidized. So that's the whole purpose of the exercise. So now we know that in this state, what happens is that nitrogen is kind of gaining electron charge, yeah, when it's bonded with hydrogen to form ammonia, right? So it's attracting electrons to itself, and that's what happens. So we say that it's reduced. So when I talk to you and say, oh, in a Haber reaction, nitrogen is reduced, and you say, oh, I see. The nitrogen kind of like grab more electrons to itself and leaving the hydrogen here high and dry. So that's the whole process of this exercise, is to kind of figure out what the electrons are doing, where is it going, and it's just another tool, another method to kind of imagine what is happening at the molecular level. And next time we're going to talk about agents. There's redox agents. What? And it's not about James Bond.